Trig Ratios, Part 5, Tangent, by Jeff Simpson, MasteryLearningSystems.com. Math books tell us that a tangent is a ratio comparing the opposite and adjacent sides of a right triangle. This video shows why this ratio is called the tangent. Let's begin by examining the relationship between circles and straight lines. Did you know you can make a circle out of straight lines? Begin with a point and two perpendicular lines, then draw a point where the lines intersect, then make copies of the two lines and rotate them about the center point. Do that again and again and again and so on until you've gone all the way around. Ta-da! If you connect all the points of intersection and erase all the perpendicular lines, you can see the resulting circle. Here are the two original perpendicular lines. If a line touches a circle at one point, it's a touching line. The Latin word for touching is tangent, so math people call this a tangent line, or just a tangent. Wherever the tangent touches, it makes a right angle when connected to the center by a radius. If you draw a tangent and a radius, and then erase the lower part of the tangent and the radius form a square corner. A tangent segment and a radius can form part of a square, or they can form part of a right triangle made from half of the square. And that would give us a 45, 45, 90 degree isosceles right triangle. A tangent and a radius can also form part of a rectangle, or as you might expect, a right triangle made from half of the rectangle. A tangent can also cut an equilateral triangle in half. And what will that give us? That creates a 30, 60, 90 degree right triangle. Well, what if a line cuts through a circle at 2 points? It's not a tangent anymore, it's a cutting line. Latin word for cutting is secant, so math people call this a secant line, or normally just a secant. Secants can cut through the circle in any direction. Here's a secant cutting through the center of the circle. A secant can be the diagonal of a square, or a secant can be the hypotenuse of a 45, 45, 90 right triangle made from the square. A secant can also be the diagonal of a rectangle, or the hypotenuse of a right triangle made from the rectangle. A secant can also form one side of an equilateral triangle. Then, if you draw a tangent, you get a 30, 60, 90 degree right triangle. This secant is rotating about the center of the circle. The radius of the circle meets the secant at the center of the circle. The radius and the secant form an angle at the center of the circle. As the secant rotates, the central angle grows bigger. If you have a secant and a radius, and then draw a tangent, you automatically get a right triangle. Notice part of the triangle will be outside the circle. Here's a reminder. In a unit circle, every radius is 1 unit long. If you construct a right triangle on a unit circle, the base of the triangle is always 1 unit long. If you rotate the secant, changing the angle, you still have a right triangle 1 unit wide, but the shape of the triangle changes. As the central angle gets bigger, and we'll look at a few angles here, the tangent side gets longer. 35 degrees, our tangent side will be a little longer than the first one. And if the angle is 40 degrees, tangent is getting longer. And if it's 45 degrees, then the tangent actually is 1 unit. You can take a right triangle of any size and reduce it onto a unit circle. The radius, of course, is always 1. Here are a few examples comparing the length of the tangent to the length of the radius. When the central angle is 20 degrees, the tangent side of the triangle is shorter than the radius. But when the central angle is 30 degrees, then the tangent gets longer. And when the angle is 40 degrees, the tangent is almost as long as the radius. When the angle is 45 degrees, the tangent is exactly the same length as the radius. When the angle is 50 degrees, the tangent is a little longer than the radius, and when the central angle is 60 degrees, the tangent is quite a bit longer than the radius. In a unit square, every side is 1 unit long and every angle is 90 degrees. A ratio compares two numbers. For a unit square, the ratio of the length compared to the width is 1 to 1. Here's 3 ways to write this ratio, 1 to 1. A unit square fits on a unit circle like this. The ratio of the tangent to the radius is 1 to 1. There's the tangent and there's the radius. A 1 to 1 ratio. But no matter how big a square is, you can fit it onto a unit circle. But what if the square is 2 by 2? I'll just use division to reduce it to the right size. There, it fits. The ratio comparing the tangent side of a square to the radius side is always 1 to 1, even if the square is 2 by 2. The diagonal of a square cuts the 90-degree angles in half. So each acute angle is 45 degrees. In case you didn't know, acute comes from a Latin word meaning sharp as a needle. You can cut a unit square in half with a secant. That makes a right triangle 1 unit high and 1 unit wide with a central angle of 45 degrees. And the tangent to radius ratio is still 1 to 1. There are several ways of describing this situation. Here's a rather wordy but complete description of this situation. The tangent to radius ratio of a right triangle whose central angle is 45 degrees is 1 to 1. That's true, but way too many words. So let's cross out some of these words and compress it to tangent to radius ratio of 45 degrees is 1 to 1. But that's still too many words. Let's get rid of some more. Tangent ratio of 45 degrees is 1 to 1. Let's get rid of the word ratio. Tangent of 45 degrees equals 1 to 1. And actually we can boil it down more than that. Tangent, we'll leave off of, tangent of 45 degrees equals 1. That's our abbreviation. Yeah. Okay, weirdness alert. What you're about to see is disturbing. It's true that a ratio compares two numbers. So is this a ratio? Well, yeah. The ratio is 3 to 4. But it can be reduced. And you're thinking, what? You can't reduce 3/4. You can. Divide them both by 4. You get a decimal on the top and a 1 on the bottom. So, yeah, our ratio is now 75 hundredths to 1. Okay, here's another one. Is this a ratio? 3 over 3. 3 to 3. Yeah, the ratio is 3 to 3. But it can be reduced to 1 to 1. Here's another one. 3 over 1. Yeah, that's a ratio. It's 3 to 1. It's pretty obvious. But it can be reduced further to just the number 3 by itself. 3 over 1 equals 3. Well, any number divided by 1 doesn't change, so the 1 in the denominator can be eliminated. All right, here's where it gets really weird. Is this a ratio? Just the number 3 all by itself? Well, it doesn't look like a ratio because there's no number on the bottom. But it is a ratio that has already been reduced. The ratio is 3 to 1. Well, you can imagine an invisible 1 under the 3 if you want. Sometimes a ratio does not look like a ratio. How about this? Tangent over radius. Well, it looks like a ratio, but it can be reduced. How are you going to do that? Well, the radius of the unit circle is 1, so the 1 in the denominator can be eliminated. Tangent over radius equals tangent over 1 is just equals tangent. Okay, here's the craziest one of all. Is this a ratio? Just the word tangent. Well, it doesn't look like a ratio because there's no number or word on the bottom, but it is a ratio that has already been reduced. The ratio is tangent compared to 1. And again, you can imagine an invisible 1 under the word tangent if you want. Tangent is the same as tangent over 1. Was it the same as tangent over radius when it's constructed on a unit circle? A secant can be the diagonal of a square. Well, we knew that. Well, how about this? Secant can form one side of an equilateral triangle. Yeah, we knew that too. But let's investigate this further. If you draw an equilateral triangle with a base 2 units wide, well, then every side measures 2 units, of course, and all the angles measure 60 degrees. Now, if you bisect this with an altitude, you get 2 right triangles, each 1 unit wide. And the angles now measure 30, 60, and 90 degrees. Looking at one of the right triangles, we can use the Pythagorean theorem to find that the height of this triangle is the square root of 3, or some people just call that rad 3. Rad 3 is about 1.7320, well, that's a long one. Well, actually, it's an infinitely long irrational number. And we could just round that to 1 73/100. Since this right triangle is 1 unit wide, watch what we can do with this. Here is our unit circle. Ha! It fits perfectly on a unit circle. The tangent to radius ratio of a right triangle whose central angle is 60 degrees is about 1.73 to 1. Too many words. Let's just use the abbreviation. Tangent 60 degrees equals 1.73. That's our official abbreviation. Now take a look on the left and you can see more precise math. Let's have another look at this equilateral triangle that's split into 2 right triangles. Take the triangle on the right and rotate it. Does it fit exactly onto a unit circle? No, because its length is about 1.73 units, rad 3. The triangle must be reduced in size if that's going to fit onto a unit circle. Well, the base of the triangle is the square root of 3. To reduce the base to 1, we will divide it and the other sides by rad 3. Here's how we'll do that. Here's our triangle. The tangent is 1 unit. Radius is 1.73. And the secant is 2 units. Here's our unit circle. Now, reduce the size of the triangle by dividing each number by rad 3. Let's start with the radius. Rad 3 divided by rad 3, of course, is 1. So we'll reduce the size of the triangle. The radius is 1. Ta-da! Now, let's take the tangent. 1 divided by rad 3 is 1 over rad 3. That's the length of the tangent. Now, there's no irrational numbers are allowed in the denominator. We'll have to have another look at that in a minute. Secant is 2 over rad 3. Same problem. Okay, here's our tangent, 1 over rad 3. But no irrational numbers are allowed in the denominator. So let's take 1 over rad 3, and we'll multiply it times a creative form of 1. Thank you, Mr. Cavender. And it turns into rad 3 over 3. That's actually the same length, it's just with a different name. So we can say, yep, the length of the tangent is rad 3 over 3. Length of the secant is 2 over rad 3, and we'll multiply that and rename it as 2 rad 3 over 3, and that's the length of our secant. Well, you've been told that irrational numbers are not allowed in the denominator. Well, why not? I mean, if you want to put one down there, why can't you? Here's why. A number over a number indicates division. And remember, rad 3 is 1.7 blah, blah, blah. It's an infinitely long irrational number. Okay, then which long division below looks easier to you? Rad 3 over 3 is an infinitely long irrational number divided by 3. Well, we can do that. You just get another long number. Well, compare that to 1 over rad 3. That's 1 divided by an infinitely long, oh man, where would you start with that? Yeah, well, that's why we don't want to have irrational numbers in the denominators. They're pretty hard to deal with. So the tangent of 30 degrees at first sight is 1 over rad 3 compared to 1. But if we say that we rename it, the tangent of 30 degrees is rad 3 over 3 compared to 1, it's a lot easier to calculate. It's 0.577, it's another one of those long numbers. We'll round that to 0.5774. Let's take a look at some easier ones, shall we? The tangent of 20 degrees is about 0.36 to 1. The exact numbers down below. Tangent of 40 degrees is about 0.8 to 1. And tangent of 50 degrees is about 1.2 to 1. You can see it's getting longer than the radius. Well, here's another classic shape, the 3, 4, 5 right triangle. How would we go about fitting that onto a unit circle? There it is, 3, 4, 5. Well, we can reduce the size of the triangle by dividing each number by 4. Let's see what happens when we do that. Well, the ratio now is 75 hundredths to 1 to 1 and 25 hundredths. There we reduce the triangle, and here is our equivalent ratios, or numbers. Since this right triangle is 1 unit wide, it fits perfectly on a unit circle. Ta-da! The tangent ratio of this triangle is 0.75 to 1. Well, that's good, but something is missing. What's the central angle? We don't know. Well, to find out, enter in your calculator 75 hundredths, second, inverse tangent, and your calculator will tell you that the angle is 36.869. It's another one of those infinitely long irrational numbers, and we'll just round that to 36.9. So the tangent of 36.9 degrees is about 75 hundredths. Here's another question. What if we know what the central angle is? Let's say 32 degrees, for example. And we know the radius is 1 because it's a unit circle, but we don't know the length of the tangent. What do you do about that? To find the length of the tangent, enter in your calculator 32, tangent, and the calculator will tell you the length of the tangent is 0.624, blah, 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 long number. We'll round that to 62 hundredths. So the tangent of 32 degrees is approximately 62 hundredths. Looking at a right triangle from the perspective of the central angle, angle A, we have the two legs that form the right angle. There's the opposite leg and the adjacent leg. And then, of course, you've got the hypotenuse, which is opposite the right angle. So here they are. Angle A, opposite side, the adjacent leg, and the hypotenuse. But earlier in the video, we constructed this on a circle with central angle A, the secant, the radius, and the tangent. Well, let's have a look at both of these ways of naming. Box 1, we've got the opposite, adjacent, and hypotenuse. Box 2, it's the same triangle, but now we're calling the sides the tangent, the radius, and the secant. Let's look at just the ratios we can get from this. Box 1 will compare the length of the opposite side to the length of the adjacent leg, and box 2 will compare the length of the tangent to the length of the radius. Well, tangent compared to radius is actually the same thing as opposite compared to adjacent. But remember, we're using a unit circle, so the radius is 1. And tangent over radius, actually we're going to eliminate radius since it's 1, don't need it, and we'll just call it tangent, which is the same as opposite over adjacent. And that's our definition. Tangent, I'll put a T there for tangent, is equals opposite, there's an O for opposite, over adjacent. TOA, tangent equals opposite over adjacent. TOA, I bet you've seen that before. Your teacher probably told you all about SOHCAHTOA. Well, that is why a ratio comparing the opposite and adjacent sides of a right triangle is called the tangent. 2 points then. A tangent is a line that touches a circle at one point. But a tangent is also a ratio comparing the lengths of two sides of a right triangle, the opposite compared to the adjacent, or the tangent compared to the radius, when it's constructed on a unit circle. How you actually use this information about tangents will be addressed in another video. You can use a calculator to find the tangent of any angle up to 90 degrees, or you can look in an old trigonometry book and use the trig table, which will look something like this. You got all the angles and the length of the tangent segment. Well, that's it. Thanks for watching my video. Please share these ideas with people who can benefit from them. Bye.